We're here in the harbour of St. John's, Newfoundland, and we'll be departing later this afternoon for transit from St. John's back to Galway. And during that transit, we'll be doing a trilateral seabed mapping initiative. It's an exciting initiative that's grown out of an agreement called the Galway Declaration that was signed between the three jurisdictions, the European Union, the United States and Canada, to look for opportunities to collaborate on research initiatives that focus on a better understanding of the North Atlantic Ocean.
To understand the oceans and the major changes in the oceans is one of mankind's great quests at the moment. Doing these type of surveys, mapping the seafloor, observing the ocean, is really important to get a handle on the changes that are happening. These changes are associated with climate change and other factors, so this collaboration and many others are going to be really important for our future.
We really have no idea what's down there in any great detail. We have a better understanding of what's on Mars and Saturn, and yet we have no real image of what's on our own seafloor. We have largely relied on satellite altimetry data, which gives us an indication of what's there. But on this survey we use acoustic techniques, multi-beam sonar, to generate 3D models of what's actually down there. The Charlie Gibbs fracture zone is one of the most significant topographic features on the bottom of the North Atlantic. They're effectively a channel between the East and West Atlantic. It's the only real deep area that cold deepwater species can migrate between the East and West Atlantic. Just to the east of the actual central part of that, we mapped one of the most significant features that we've seen on this vessel or in any program the Marine Institute has ever been involved in. We mapped a 3,500 meters high mountain, effectively, an underwater mountain. So these are very, very significant topographic features, and when you look at the comparison between the older data and the new data, there's quite a significant difference, 500 meters plus or minus depending on where you are. And that has huge implications in terms of our ability to model oceanographic currents, ecosystems, and what's actually happening in the marine domain.
Oh, it was a great opportunity to meet some experts in the area of multi-beam data acquisition, and also how to see the results of the brand new technology they have here. It's state-of-the-art technology. It's a very nice idea to have the cooperation between the European Union, Canada and the United States. Through IPMA, my institution, we hope to be fully cooperating scientific-wise in the near future, and we to be a part of it.
The Marine Institute in Newfoundland and the Marine Institute here in Ireland have had a long-standing relationship with multi-beam and seabed mapping. I think in the very near future we'll begin to add on to this recent survey with a Canadian Coast Guard vessel, Louis St. Laurent. Louis St. Laurent is going to go to the North Pole, mapping up there. So on the transit across, she has the exact same multi-beam technology that's on the Celtic Explorer.
This expedition has been extremely successful, as you'll have heard from the scientists. It was an ambition of the Atlantic Ocean Research Alliance to undertake a transatlantic survey of the seafloor together, supported by DFO in Canada and Memorial University, by NOAA in the United States, and by Ireland and Portuguese authorities on behalf of the European Union. This proves the concept works. We have had a very successful undertaking. This approach will be brought to a working group in July in Cork at Seafest, where we will look to how we can build on this approach of a patchwork quilt preparation of a map of the Atlantic Ocean. Every time you and I breathe, 1/2 of the oxygen we consume has been produced by microscopic plants in the ocean. To understand what is happening to that as a result of climate change and other changes, we need this type of underpinning, accurate, really accurate and fit for purpose map information, observations information, and then the ability to put those together into a forecasting capability, and that's our quest.